Hi everyone. So in this video, we're going to learn about second order homogeneous ODEs. So just some basic facts. And in later videos, we'll get on to more particular agendas with these equations. So I'm going to write a general second order linear ODE in the form y prime plus p of x, y double prime rather, plus p of x y prime plus q of x y is equal to 0. Okay, it's homogeneous because that right-hand side is 0. And make sure you see that's scratched out. So it's homogeneous and it's linear when it's exactly in this form. Okay, and if you could put a coefficient here, but if it wasn't non-zero, then it's not a second order equation. And if it is non-zero, you can divide by it and get it in this form. So this is a general second order linear homogeneous equation. Okay, so the question, one of the main points of this sort of equation is that you have something called the principle of superposition. And what in the world does that mean? What it means is, suppose you have two solutions. Let's say y1 of x and y2 of x are both solutions of, let's call this equation star, asterisk. Then the C1 y1 of x plus C2 y2 of x is also a solution for any C1, C2 in R, real numbers. Okay. So let's see why that's true. That says that you can take any two solutions, multiply them by any constant you like, add them up, you get another solution. And if you can do it to two of them, you could do it to three of them, because you could take these two and suppose you have another one, 3, you add them together. This, by the principle of superposition, the sum is a solution. And if I took C3 times Y3 and added it to this solution Y, then I get the sum of C1 Y1 plus C2 Y2 plus C3 Y3 is also a solution. So consequence, any finite sum of solutions, let's say y1 up to yn, in the any finite sum of solutions written in the form C1 y1 of x plus, and you keep going until you get to Cn yn of x. And if we call that y of x, this is also a solution of asterisk. Okay, so if we can show this, then any finite sum of solutions, and when you take a constant times a function and then add them all up, that's called a linear combination. If you've had any linear algebra, you know that this is called a linear combination. And so a convenient way to say it is any linear combination of solutions is, again, a solution. Okay. Okay, so let's go about showing the principle of superposition. Okay, so why is the principle of superposition true? Okay, well, let's see. So we're going to suppose that y1 and y2 are two solutions of asterisk. Okay, so that they're both solutions of asterisk. And now we look at y double prime. So first we have to do y prime. Then y prime is equal to c1 y1 plus c2 y2 prime, which is, by the rules of calculus 1, c1 y1 prime plus c2 y2 prime. Okay, and then similarly, y double prime is c1 y1 prime plus c2 y2 prime, all prime, all differentiated. Okay. And so again, by the rules of calculus 1, that is c1 y1 double prime plus c2 y2 double prime. Okay. So now look at y double prime plus p of x y prime plus q of x y. Okay, so that is by what we just calculated. C1 y1 double prime plus C2 y2 double prime plus p of x times y prime. So that will be C1 p y1 prime plus C2 p y2 prime plus q of x times y. So that will be C1 q y1 plus C2 q y2. And now let's look at that. So we have to look at that sum. So if we add these three terms together, and then add these three terms together and group them that way, what we see is that this is equal to C1 times Y1 double prime plus PY1 prime plus QY1 plus C2 Y2 double prime plus PY2 prime plus QY2. And then notice, because Y1 solves star, asterisk, as we called it, so this thing is equal to 0 by the equation. And so is this. So it's the sum of two things that are 0. So this left-hand side is 0. And that means that y satisfies the equation asterisk. And so that's it. Okay. Okay. So the principle of superposition holds for linear equations. And it's easy to see that it would fail for inhomogeneous equations. Okay. Why? So let's note superposition fails for inhomogeneous equations. Because an inhomogeneous equation, remember, can be written in the form y double prime plus p of x y prime plus q of x y is equal to h of x or g of x. It doesn't matter. I'm starting to write h, so let's leave it at that. Okay. All right. And then, and h is not equal to 0. So this is not identically 0. Okay. So what if I take two solutions? So I'll call this one double star. Suppose y1 and y2 both, whoops, this pen is running out of ink. I'll grab a different one. Suppose y1 and y2. Oh dear. Oh, let me grab another pen. Okay, so we're back with a pen that works. So suppose y1 and y2 are both solutions of double star. then what happens to, let's look at y is the sum of y1 and y2. So I could say a constant times it, but I'll make my point with C1 and C2 being 1. Okay. Now, what happens when I take y prime? Well, we already saw that y prime is y1 prime plus y2 prime, and we know our calculus 1. And y double prime is y1 double prime plus y2 double prime. So if I look at y prime plus y double prime plus py prime plus qy, I get y1 double prime plus y2 double prime plus py1 prime plus py2 prime plus qy1 plus qy2. Okay, and now let's group those together in a particular way. We're going to group all the y1 things together. So everything in pink is grouped together, and now everything in bronze will be grouped together. There we go. That's bronze. I'm not sure if that comes across well in the video. And so from the pink items, let me go ahead and write that in pink. The pink items together give me, because y1 solves this equation, the pink items give me h of x. And then because everything's circled in bronze, in other words, y2 satisfies this equation, that gives me h of x. So if I take the equation for y and look what I get as the right-hand side, I get 2 times h of x, which notice is not equal to h of x. So y does not satisfy double star. So superposition fails for inhomogeneous equations. Okay, that's it for today's video.